Hello everyone and welcome to this lecture on pre-processing for text and images. So far we have studied a few pre-processing techniques, but they usually work on the structured data. So you have the data available in the form of a table. Sometimes some values are missing, so we have pre-processing techniques for the same. We applied normalization techniques and so on. But sometimes we have unstructured data in the form of an image or text, and there the traditional pre-processing techniques might not be applied directly. So in this lecture, we will discuss what are the pre-processing techniques that can be used for image and text, which changes that change image and text, and finally supply the pre-processed image and text to the machine learning model or deep learning model. So let's start with this topic. As a recap, so far we have seen how to deal with missing values. So when we have the structured data, sometimes some values are missing. We also talked about feature scaling, the normalization and standardization. And also there is a very commonly used pre-processing step of converting categorical values into numeric values sometimes, and vice versa, which is also called data discretization, where you have the numerical values and you want to put them into categorical values. Once again, these techniques are useful when your data is more into an structured form. However, they cannot be directly applied on the image data and text data. So in today's lecture, we'll focus on what are the different pre-processing techniques for image as well as text. So we will first start with images. So there are a few commonly used pre-processing operations that can be applied on images. It is important to remember that in some machine learning and deep learning tasks, the input are images, right? So we need to convert those images into an appropriate form, so that when this input data set of images goes into the models, then it improves the performance of the model, and it might reduce the complexity that is required to train the model. For that, we use these commonly used pre-processing steps. Let's discuss each one of them one by one. The first one is the grayscale conversion, and what it does is it converts the color images to black and white images or grayscale images with shades of gray. So on one extreme we have the black color, on another extreme we have the white color, and in between we can have shades of gray. Usually in the case of grayscale image, all the pixels of the images have values in this range, where 0 represents a black color and 255 represents the white color, and all the values in between represent the shade of gray. Now what grayscale conversion does? It reduces the complexity for the further image processing and analysis tasks. In some cases you will find that the colors are not that important, but let's say you want to identify where are the edges in my image, where are the certain shapes in my image. In those cases, having color information will not help much, and we can convert all the images into grayscale first, and then we can do the further processing. For your information, images, as you already know, images are made up of pixels, and each pixel in the case of color image usually have 3 different values. One pixel has 3 different values, one for red color, one for green color, and one for blue color. But when we convert that into grayscale image, then the same pixel has only now one value ranging between 0 to 255. So you can consider that this pre-processing step of grayscale conversion reduces the complexity of the overall data set by 1/3, because now we are not keeping 3 values, we are having only one value. Sometimes, and by the way, grayscale images, they are also called single channel images. because we have only one value per pixel. But usually normal images, they are colored in nature and they are called 3-channel images, because here you have 3 values for each pixel. Maybe red, blue and green RGB is a very common convention for color images. So sometimes we do the grayscale conversion, means we take the colored image, convert that into the grayscale image, and sometimes we take the grayscale image, means single channel image, and convert that into 3-channel images. Now, why this kind of conversion is required? Obviously, it will increase the size and it will increase the overall complexity. But this process typically involves that rather than making a grayscale image to color image, if you view the 3-channel image converted from the grayscale image, you will not see colors, because this process of one channel to 3-channel conversion, it typically involves duplicating the same grayscale values across the 3 channels. Now the result is a grayscale image representing in a color space format, but it will still appear as shades of gray when viewed. The obvious question is why this kind of conversion is required, even if we cannot see the color in that image. In some models, you will see that, especially in the case of transfer learning, it is a subcomponent of deep learning. In transfer learning, we have pre-trained model which take input in a certain format. Means they can process only those images which are 3-channel images. That is, they contain the value of red and green and blue. Now, in these predefined models, you cannot insert a grayscale image as such. So, in order to use those pre-trained model, we need to first convert our grayscale image, the single channel image, into a 3-channel image. Then only we can pass them into these pre-trained models. So in those cases, we sometimes require this operation also. Then we also have the image normalization process. It is similar to what we do in the traditional way when the data is structured and arranged into columns. But normalization in images, it adjusts the pixel values in an image so that they have a specific mean and standard deviation. It's often used to bring different images to a similar scale for comparison or further processing. Then we have the resizing and rescaling. So it means changing the size and dimension of an image, and it also needs to be done in many cases because the input image, the input data might have images of different sizes and different resolutions, and we need to bring all of them to the same size. In those cases, resizing as a pre-processing steps become really important. Then we have this process of data augmentation. Sometimes when we are dealing with the input images, the data set is relatively small and we want to increase the size of the image data set. For that, that's why the name augmentation means you want to add more data to the existing data. For images, what we usually do is we try to create new training images from the original images by applying some kind of transformations. Usually these transformations are random, but commonly used transformations are rotation, which means we can rotate the image, we can flip the image, also called the mirroring. What it does is it increases the diversity of data for training models, particularly used for deep learning models. We will see that with the help of an example later on. So this kind of analysis is very, very common, but there are other types of pre-processing steps also, like noise reduction. We want to reduce the noise which is there in the image. We sometimes are interested in feature extraction within the images. So we try to extract specific characteristics or features from an image, such as edges, corner, and so on. But these 5-6 pre-processing steps related to images are very common. Now let's discuss each one of them one by one. So grayscale conversion, as you can imagine, you have been given a colored image, and using some operation we convert that into grayscale image. Now obviously, once again, let's discuss what is the benefit. So converting color images into grayscale images, as I told you earlier, reduces the complexity of the model and helps in further analysis. It also, this kind of conversion is often used when we focus more on extracting the features of the image. So maybe many application algorithms such as age detection is there, and texture recognition is there. They primarily concerned with the structure, shape, or texture of the objects in an image rather than the colors. So grayscale conversion is used, so it reduces the complexity and it helps us focus more on these characteristics. This is the image normalization process. So I have considered the pixel values of a 2x2 image, if you will. So you can consider that this is an image made up of only 4 pixels, and it is a grayscale image. So we have only one value per pixel. So 0 here represents it is a black color, 255 represents it is a white color, 45 is more close to the black color, so darker shade of gray, and 168 is closer to 255, so lighter shade of gray. Now if we want to normalize that, what we usually do is we divide all these pixel values with the maximum value possible, which is 255. This operation is very common. So when we apply normalization and divide each one of them with the value 255, then we get these normalized values. Obviously 0 will remain 0, 255 will become 1, and 45 will become 0.176, and 168 will become 0.659. So what it does, it brings all the values within the range 0 and 1, and we do that for all the images which are there in the training data set and later on to testing data set as well. Then there is resizing. So resizing changes the shape of that image on the horizontal axis and vertical axis. So there are many inbuilt functions available in Python library to do the resizing and rescaling also. Then we have this concept of data augmentation. It is used to increase the diversity of the training data set by applying random but realistic transformations. So this technique helps improve the robustness and accuracy of different machine learning models that we'll discuss later, especially in the case of deep learning applications where amount of training data may be limited. Here are some of those augmentation techniques. First of all, we can do the rotation. So rotation, as the name implies, we rotate the image by a random angle within a specified range. And then we have this flipping option to change the image. So what it does, it mirrors the image either horizontally or vertically, and it gives variability in the data set also. We can also apply cropping. So cropping means you have been given this image and you crop that to some specific object or some specific scene of that image. We also have this option of color shifting, where if it is a color image, then we change the color of the image and present that as a new image. So let's see the examples of all of them one by one. So this is the rotation operation. We have taken this image and maybe we have rotated it around 45 degrees here, right? So you can see, you can focus on trees. So trees are vertical here, and in this case they have been, some 45 degree or 60 degree angle they have been, so the whole image is rotated to some degree. We have flipping. So in this case, this image is the mirror image of the left hand side image. You see in this case the sun is on this side. In this case, the sun is on that side. Just the mirror image. Then cropping. So in cropping, this has lots of background information in that. But in this specific image, after cropping, we have focused more on the object, which is dog in this case. So this cropping is also one of the very commonly used data augmentation operation. We also have this operation of color shifting. What we have done is we have added some values, maybe sometimes even randomly, to the pixel values of the original image to this image, and we have shifted them to some new value. Maybe we have added some values, maybe let's say 18 into all the previous RGB values, and what it does is it shifts the image into a new color domain. So these operations are very common. Now, what is the benefit? The benefit is this was the original image and it is the new image. So if we simply apply only the color shifting on the original data set, let's say if the original data set had 5,000 images, then just by applying color shifting, we can have a total data size of 10,000 images, where 5,000 are the original images plus 5,000 are the new images that have been generated after applying this operation of color shifting. So these are some of the common operations that we perform on images before applying some kind of machine learning and deep learning model onto that. Then we have the text preprocessing operations also. So sometimes our input data is text, and text preprocessing is a critical step in the domain of natural language processing and machine learning tasks also, which involve text, and it requires cleaning and standardizing the textual data to make it suitable for analysis and modeling. So you will find some applications where we do use text as input. For example, spam filtering. In spam filtering, we have the text of an email, and on the basis of that, we have to decide whether this given email is an spam email or not, right? So that the text of the email that we get is just sentences, right? Words and sentences put together in the form of maybe some paragraph, that email. So how do we identify that, whether that is an spam email or no? We apply some machine learning technique on that. But we do not directly supply text to the model. We first pre-process that whole text using these operations, and then only when it is in a particular form, then only we pass it to the machine learning model, which can further identify whether this given email, which has been pre-processed already, is an spam email or not. All right. So these are some of the common operations. Lower casing means converting all characters that are there in the text to lowercase to uniform the case usage. That means that if you have some uppercase characters and some lowercase characters, you just convert all of them into one case, usually the lowercase. Then we have seen that when we do this kind of analysis of spam filtering, punctuation marks, they are not very useful in the meaning of the text. So if you have comma, if you have exclamation mark, if you have question mark, it does not add much to the meaning of the text. So we remove those punctuation marks also. We also commonly apply this operation of tokenization. Tokenization usually represent that we break the given text into individual words, also called tokens. Sometimes we also break them down into characters. So token means you have been given this whole text, and you are splitting them into smaller components. Usually words are good choices for tokenization. Then often before supplying the text into the machine learning model, we also remove the stop words. So stop words are those commonly used words that once again do not usually carry much meaning related to the text, in this case email. So if you have the words like is, that, right, and all of them are example of stop words, and they do not add much into the meaning. Then we have the stemming. Stemming means we keep the root part and we remove the verb to which it is associated. So for example, if there is a word running in the text, then we just remove the ing part and keep the run, because run is something that might help in decision making, but its different forms, right? Running or ran might not be very useful, so we remove them. Stemming sometimes give you semantically incorrect words also. So for example, often if we have words like include, and when it goes through the stemming process, it might give the value only this. So usually the and is are also removed in the process of stemming, and we know that this is not a meaningful word. So another process is lemmatization. What it does, it also removes the verb form. It keeps the original root of the word, but it keeps the more semantically correct word rather than some word which does not carry any meaning. Then often in the text processing, some numbers appear, so we remove the numbers. Some extra spaces, tabs appear, so we remove them also. Sometimes URLs are also given, the link of some websites, so those URLs are often removed or replaced with some common word, let's say URL address or something. Sometimes emails are also there within the email body, let's say within the text, email is also mentioned, and we sometimes remove those email addresses also, or maybe replace them with some common word like email address, because the basic idea in text pre-processing that we remove those things which do not add to the meaning of the sentence for the machine learning model, and also we break the huge text down into smaller chunks. We call them tokens. So let's see the example of these pre-processing steps one by one. So let's say this is my input statement. The quick brown fox jumps over the dog! Exclamation mark. This sentence includes numbers like 1, 2, 3 and symbols like double question mark. So we have, let's say, some sentence like this. When we apply lower casing, then this sentence looks like this, where each character is in lowercase. So you see that this T, capital T, has been replaced with a smaller t. This capital T has been replaced with a smaller case t. Then punctuation removal. So once we have applied the lower casing, we already know that T is small. Then further, when we remove the punctuation, then this exclamation mark is removed. These question marks have also been removed. Even the full stop mark is also removed after this operation of punctuation removal. Now let's say after that we do tokenization on the processed text. So if we take this text and we break them down into individual words, let's say words are the tokens, and we have considered space as the criteria for tokenization. So you see that the is a separate word in this list now, quick is a separate word, brown is a separate word, and all of them are being considered as separate tokens after the process of tokenization. Then stop words removal. So the common words like the here and the here also, over, right, all of them, all of them have been removed because they are the commonly used words and they do not add much into the meaning of the sentence. Let's move forward and apply the further operation. Let's say we want to do the stemming on this tokenized sentence. When we do the stemming, what it does is it keeps the root words and it removes the different forms of the verbs. So say this S has been removed and we keep the word jump. So this is the basic rationale behind stemming. So symbols has been replaced with symbols. This is another example. But sometimes, as I told you earlier, stemming might give you semantically incorrect words. So if you look at this sentence, it has been replaced with this sentence with a missing E here, and we know that this is not a meaningful word. Similarly, for includes here, you see include with no E, so that is once again is not a semantically correct word. So this is what stemming does, but the basic idea is we keep the root words and we remove the verb forms. So lemmatization but is similar to stemming, but the difference is that it keeps the meaning of the word intact. So jumps once again has been replaced with jump. Symbols, it has been replaced with symbol. But sentence, if you look at there, the E has not been removed, it will remain sentence. Same is true for includes also. It is there. So this is the process of lemmatization. Finally, let's say final pre-processing step is removing the numbers. So in this case, if any number appear in the text like 1, 2, 3, it has been removed. If you apply other types of removal like removing the URL or replacing that with something else, then that can also be one of the pre-processing steps. So it is important that we have seen a few image and text pre-processing approaches, and we have seen the examples for the same also. But when we implement them for the machine learning task and deep learning tasks, you will find that we do not write the code for all these pre-processing steps usually, because we have a very good set of libraries available in Python that can directly apply all these pre-processing steps for you, right? So we just import the necessary libraries, we supply them the necessary data, we customize them for the specific pre-processing task, and they do the job for us. So we do not write the code from scratch, and implementing all these pre-processing steps is very easy. In fact, using the Python libraries. So as we come to the conclusion of today's lecture, what we have discussed is that the image processing and text processing approaches, they are different from traditional approaches of pre-processing like missing values and all. And for image processing, the commonly used steps are grayscale conversion, normalization, data augmentation, and there are a few others. For text pre-processing, we apply methods like converting the whole text into lowercase, removing the punctuations, tokenization, lemmatization, and there are some other pre-processing steps also. Once we do these pre-processing steps, now our image or our text is ready to be fed into the machine learning model or deep learning model for further processing. As we'll go forward into the further lectures, we will see how we can directly apply these techniques with the help of inbuilt Python libraries. So this is all for this lecture. Thank you.